In this video, we will discuss scale as it relates to models. We will start with an outline of a person. For this discussion, this person is 180 centimeters or 5 feet 10.87 inches. We now have an additional illustration to represent this person. As seen, the copy of the illustration is the same height. Since both the original and the copy are the same height, this gives us a scale of 1:1. Now the second illustration is 90 centimeters or 2 feet 11.43 inches. Because of this, we now have a scale of 1:2. Our illustration is now 18 centimeters or 7.087 inches. We now have a scale of 1:10. In this view, we can see a table of data. This table starts out with the dimensions of our illustration for our person at 1:1 scale. As we move through the table, we can see how the different scales will affect the dimensions for the height of our person. Although these are not all the scales in modeling, the scales on this table were chosen because they are common for different types of models. These models would include die-cast tractors, farm machinery, aircraft, cars, trucks, and also trains. Considering the models mentioned, trains have a wide range of scales beyond what is seen here. That being said, this list should be a good indication for what the height of this person would be if it was a model figure at all these different scales. The use of consistent scale can also be demonstrated with multiple models. In this view, we've added an illustration of a John Deere Model A tractor along with the person. As seen, our person is still 180 centimeters or 5 feet 10.87 inches. The John Deere tractor is 162 centimeters or 5 feet 3.875 inches at the hood. The tractor is also 203.2 centimeters or 6 feet 8 inches to the top of the exhaust pipe. Although these dimensions may not be exact for the tractor, let's just use them for this discussion. As a side note, with the tractor and person together using the same scale, this can help us visualize their relationship to each other or how big things are compared to what we know. We will finish with this table showing the height of the tractor and the person in multiple scales. 1:16, 1:32, and 1:64 are common scales for farm tractors and agricultural machinery models. That being said, this data also gives us a relationship between these two illustrations and the dimensions of height if they were modeled at these different scales. In this next example, we will look at a track for a railroad, also known as railway track. The width between the track is called gauge or track gauge. At 1:1 scale on a real railway track, there are multiple widths or multiple track gauge. For this example, we will use standard gauge. Standard gauge or standard gauge railway is a track gauge of 1,435 millimeters or 4 feet 8.5 inches. In this view, we can see our standard gauge railway track, John Deere tractor, and person at 1:1 scale. This table is meant to compare and demonstrate the width of standard gauge track at different scales. The column titled Track Gauge includes gauges from model railroad as a general reference to scales listed. Some of the scales or track widths may be different due to variations in the gauge and scale done by model railroad manufacturers or by region. For example, model railroad O gauge uses a different scale in different regions. Model railroads also may use different dimensions for the actual track width as compared to the scale that they market for the size of locomotives, rolling stock, or buildings. Aside from the standards and specifics to regions and manufacturers, this table is still useful to help communicate the general concept of scale and scale models. We're just getting started, so if you haven't yet, subscribe now. Thank you for watching this video about scale in modeling. Comments and likes are welcome.